Hello students, today let's learn triangles. A closed figure formed of 3 or more line segments is called a polygon. A polygon with 3 sides is called a triangle. It has 6 elements, namely 3 sides and 3 angles. The adjoining figure shows triangle ABC. The 6 elements of this triangle are side AB, side BC, side AC, angle A, angle B, and angle C. A, B, and C are 3 vertex. Types of triangles. Triangles are classified on the basis of their sides and angles. Based on the congruence of the sides, the triangles are classified into 3 types. First, equilateral triangle. If all the 3 sides of a triangle are congruent, then the triangle is called an equilateral triangle. Second, isosceles triangle. If any 2 sides of a triangle are congruent, then the triangle is called an isosceles triangle. Third, scalene triangle. If no 2 sides of a triangle are congruent, then the triangle is called a scalene triangle. Based on the types of angles, the triangles can be classified into 3 types. First, acute angled triangle. If all the angles of a triangle are acute, that means less than 90 degrees, the triangle is called an acute angled triangle. Second, right angled triangle. A right angled triangle is a triangle in which one angle is a right angle, that is 90 degrees. And third, obtuse angled triangle. An obtuse angled triangle is one with an obtuse angle, that is greater than 90 degrees, and 2 acute angles. Note: no triangles can have more than one obtuse angle. Here, name of the triangle, triangle ABC. Sides of the triangle, side AB, side BC, side AC. Angles of the triangle, angle BAC, angle ABC, and angle ACB. Here, when side AB is congruent to side AC, it is an isosceles triangle. When side AB is congruent to side BC and side BC is congruent to side AC, it is an equilateral triangle. When AB is not equal to BC and BC is not equal to AC, it is a scalene triangle. And when AB square is equal to AC square plus BC square, it is a right-angled triangle. Thank you for watching. Hello students. Today let's learn cVin. A cVin is a line segment which joins a vertex of a triangle with a point on the opposite side. Draw triangle ABC. Take 3 points P, Q, and R. Join them with a vertex opposite to each of them. The segments AP, BQ, and CR so drawn are called cVins. Even vertex have infinitely many cVins. Types of cVins. First, median. The line segment joining the vertex of a triangle to the midpoint of its opposite side is called a median of the triangle. Triangle PQR. D, E, F are midpoints of PQ, PR, and QR respectively. Segment PF, segment QE, and segment RT are the medians. Medians of a triangle are called centroid of the triangle. The centroid divides each median in the ratio 2:1. Second, altitude. A perpendicular segment drawn from the vertex to its opposite side is called an altitude of the triangle. Here, segment DM is perpendicular to segment EF, segment EN is perpendicular to segment DF, segment FP is perpendicular to segment DE, and segment DM, segment EN, and segment FP are the altitudes. Point of concurrence orthocenter is O. The altitudes of a triangle are called the orthocenter of the triangle. Third, angle bisector. The line segment which divides an angle into two angles of equal measure is called an angle bisector. Segment AP, segment PQ, and segment CR are the angle bisectors of angle A, angle B, and angle C respectively. The point of concurrence is the incenter I. The angle bisectors of a triangle are called the incenter of the triangle. Thank you for watching.
Theorem 1. The sum of the measures of the angles of a triangle is 180 degrees. This theorem states that if three angles of a triangle are added, it should be 180 degrees. To prove this, we are going to draw a triangle with the name PQR, such that angle P plus angle Q plus angle R is equal to 180 degrees. After drawing the triangle, we are going to draw a line passing through point P such that line ST is parallel to side QR. Given, triangle PQR is any triangle. To prove, angle QPR plus angle RQP plus angle PRQ is equal to 180 degrees. Construction. Draw a line ST through the point P such that line ST is parallel to side QR. Prove, as line ST is parallel to side QR, PQ becomes the transversal. Thus, as we know the converse of alternate angles test, angle SPQ is congruent to angle PQR. As line ST is parallel to side QR, PR becomes the transversal. Thus, as we know the converse of alternate angles test, angle TPR is congruent to angle PRQ. Now, we are adding equation 1 and equation 2. Angle SPQ plus angle TPR is equal to angle PQR plus angle PRQ. Just to get the angles on both the sides, we are going to add angle QPR on both the sides. Therefore, angle SPQ plus angle TPR plus angle QPR is equal to angle PQR plus angle PRQ plus angle QPR. Therefore, angle SPQ plus angle TPR plus angle QPR is equal to angle PQR plus angle PRQ plus angle QPR. As we know, angle SPQ, TPR and QPR are linear pair of angles. Thus, by the sum of angles in a linear pair is 180 degrees. 180 degrees is equal to angle PQR plus angle PRQ plus angle QPR. Therefore, angle QPR plus angle PQR plus angle PRQ is equal to 180 degrees. The sum of the measures of the angles of a triangle is 180 degrees. Hence, exterior angle of a triangle. The angle forming a linear pair with the interior angle of a triangle is called an exterior angle of a triangle. In the figure, angle PRS and angle QRT are the exterior angles of angle PRQ. Remote interior angles. For angle ABC, angle ACD is an exterior angle. Angle ABC and angle BAC are the remote interior angles of the exterior angle, angle ACD. Theorem 2. Remote interior angles theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. To prove this theorem, we are going to draw a triangle PQR. Now extend the side QR so that R lies between Q and M. Given in triangle PQR, M is the point on ray QR such that QRM. Angle PRM is an exterior angle of the triangle. We are going to prove exterior angle PRM is equal to sum of two interior angles, that is angle PQR and angle QPR. Proof: in triangle PQR, as we know from theorem 1, sum of angles of triangle is 180 degrees. Angle PQR plus angle QPR plus angle PRQ is equal to 180 degrees. And hence, by angles in linear pair, sum of angle PRQ and angle PRM is 180 degrees. Now we are going to substitute equation 1 in equation 2. Therefore, angle PRQ plus angle PRM is equal to angle PQR plus angle QPR plus angle PRQ. Thus, angle PRQ from both sides gets cancelled. Therefore, angle PRM is equal to angle PQR plus angle QPR. Hence, the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. Hence, proved. One-to-one correspondence between the sides and angles of a triangle. One-to-one correspondence is denoted by: consider two triangles, triangle ABC and triangle PQR. We can establish 6 one-to-one correspondences between their vertices. They are: ABC is one-to-one correspondence to PQR, ABC one-to-one correspondence to PRQ, ABC one-to-one correspondence to QRP, ABC one-to-one correspondence to QPR, ABC one-to-one correspondence to RPQ, ABC one-to-one correspondence to RQP. Let us consider one case: ABC correspondence to QPR. For the given one-to-one correspondence ABC to QPR, the corresponding sides and angles are as follows: side AB one-to-one correspondence to QP, side BC one-to-one correspondence to PR, side CA one-to-one correspondence to RQ, angle B one-to-one correspondence to angle P, angle A one-to-one correspondence to angle Q, and angle C one-to-one correspondence to angle R. Similarity. Note: congruency is denoted by, similarity is denoted by. For a certain one-to-one correspondence between the vertices of two triangles, if their corresponding angles are congruent and their corresponding sides are in proportion, then the triangles are said to be similar triangles. In triangle PQR and triangle KLM, if side KL proportional to side PQ is equal to side LM proportional to side QR, that is equal to side KM proportional to side PR, and angle P congruent to angle K, angle Q congruent to angle L, and angle R congruent to angle M, then triangle PQR is similar to triangle KLM. Test of similarity of triangles. First, SSS test. Two triangles are similar if the sides of a triangle are proportional to the corresponding sides of the other triangle. In triangle ABC and triangle PQR, if side PQ is proportional to side AB equal to side QR proportional to side BC and equal to side PR proportional to side AC, then triangle ABC is similar to triangle PQR. Second, AAA test. For a given one-to-one correspondence between the vertices of triangles, the two triangles are similar if the angles of one triangle are congruent to the corresponding angles of the other triangle. In triangle DEF and triangle XCY, angle D is congruent to angle EXY. Angle E is congruent to angle E and angle F is congruent to angle XYE. Then triangle DEF is similar to triangle XCY. Third, SAS test. For a given one-to-one correspondence between the vertices of triangles, the two triangles are similar if two sides of a triangle are proportional to the two corresponding sides of the other triangle and the corresponding included angles are congruent. In triangle YXZ and triangle RSN, if YX is proportional to RS, which is equal to XZ proportional to SN, and angle X is congruent to angle S, then triangle XYZ is similar to triangle RSN. AA test. For a given one-to-one correspondence between the vertices of triangles of two angles of a triangle are congruent to the two corresponding angles of the other triangle, the triangles are similar. In triangle ABC and triangle PQR, angle A is congruent to angle P, angle B is congruent to angle Q. Therefore, triangle ABC is similar to triangle PQR. We can verify that AA test is the same as AAA test. Converse of the tests of similarity. First, converse of SSS test. If two triangles are similar, then the corresponding sides are in proportion. If triangle XYZ is similar to triangle KLN, then side XY is proportional to side KL, which is equal to side YZ proportional to LN, which is equal to side ZX proportional to KN. Converse of AAA test. If two triangles are similar, then the corresponding angles are congruent. If triangle ABC is similar to triangle PQR, then angle A is congruent to angle P, angle B is congruent to angle Q, and angle C is congruent to angle R. If two triangles are similar, then the corresponding sides are proportional and the corresponding angles are congruent.